This week, we are learning about angle relationships. So I wanted to start with having you think about where do we see angles? And there are many places, more than we could even name. But there are 3 recent places that I thought about I was using angle relationships recently. First, my husband and I have been working outside and building stuff during quarantine, and we've been using ladders. So you'll see here, it says something about a plus b equaling 180. Ignore that for right now, but we are going to learn about it later. So a ladder props up against a house, and the angle at which the ladder is propped up against the house is important. If it was too close, you could tip over backwards. If it was too far away, the base, then you couldn't get very high. So when we're propping up a ladder, I've noticed that we often use our intuition as to what makes sense, but that's still using angle relationships. Another place I've used them recently is playing basketball. So in this picture, there's one player that is trying to get open. That's the 1. And the 2 is trying to pass the ball. So the 1 makes a cut, we call it a V cut. They run down and then sprint to get open. And player 2 then can pass them the ball because they lose their defender. If 1 made a different angle cut, like this, let's say, that angle is probably too shallow to be able to get open. So the way that you would make an angle cut is really important. You need it to actually be an angle and not just like a straight line to get open. And then lastly, there was an old creepy shed in our backyard, so my husband and I redid it, put on a new roof, and a lot of other work to make it usable. So this roof, you can see the green, we built, and then we wanted to build a little shelter over in another spot in our yard to stand under when it's raining and we're playing with our dog, and then to store wood for bonfires. And to make it match, we wanted the roof to be the same color, that was easy, but also the same angle as the roof of the shed. So we use different things like a protractor. We use something called the Pythagorean theorem, which you'll learn about in Math 8. And we use similar triangles to be able to calculate the dimensions we needed for the shelter so the roof was the same angle. These are all places where I've used angles just in my everyday life, really. We're going to learn about 4 specific types of angles today. Hi, Mr. M. Sadaquist. First, we're going to learn about something called complementary angles. So notice Mr. M. Sadaquist is sitting at a 90-degree angle. 90-degree is like a perfect corner or perfect L shape. It's also called a right angle. So 90-degree or right angle. Now, complementary angles, notice that's plural, means 2 angles that add up to 90 degrees. So notice here is an angle, here is an angle, and together they make 90 degrees. Another type of angle is called supplementary. So here, Mr. M. Sadaquist is laying in a straight line on the ground, and his arm is creating 2 angles. So supplementary angles make up 180 degrees. So a straight line is 180 degrees. So supplementary angles are 2 angles, 1, 2, that add to 180 degrees. Now, it can be easy to get those confused. Do they add 90 or do they add to 180? So I'm going to help you Remember a way to keep those angles straight. Notice there's two little angles here. They're complementing each other. Hi, you look great today. Wow, that smile is amazing. So, complementary angles, remember they add to 90 degrees. 90 degrees we also call right angles. So the way I remember this is that it's always right to complement. Go compliment a family member right now. Next, we have vertical angles. So vertical angles are angles made by two intersecting lines. So notice, Miss Nelson is making an X. So two intersecting lines create angles, and vertical angles are across from each other. So this angle is across from this angle. So they're across from each other and equal, which is really helpful if solving for angles. This angle is equal to this angle. And then lastly, we have adjacent angles. So notice there are two angles being made here by Ms. Nelson. We have this one and we have this one. Adjacent angles just simply mean next to. The other ones all had something to do with the angle measurement, but adjacent angles, we don't necessarily know what they might add up to or if they're equal. Adjacent just means next to. So in review, complementary angles add to 90 degrees. So this one and that one would add to 90. Supplementary angles add to 180 degrees. So this one and this one would add to 180. Vertical angles are across from each other. So in red there, red there. Also, the other direction, green here and green here. So they're across and equal. The greens are equal and the reds are equal. And then adjacent simply means next to.